Welcome to 2.3 Inverse Functions. Here we're going to be talking about regular functions and how to find their inverse in different forms, whether it's through a graph, through a table. We're going to look at those different forms and how to determine that inverse. We're going to first start off with what is the inverse of a single function. So here we have f of x is equal to 3x minus 5. The inverse of that function first is described with this -1 exponent. That is the universal method of describing the inverse of a specific function. Now, when we are looking at the x and y, generally what will occur is that it mirrors and reflects, it almost reverses the other function that you are referring to. So let's start off with understanding how to find that inverse function. In slide 3, we go ahead and go over the step-by-step of how to find the inverse of a function. So the first would be replacing f of x with y. So let's go back to our example that we were using before, which was f of x is equal to 3x minus 5. And this will be our sample problem. Our first step is to replace y with the f of x. So we would go with y is equal to 3x minus 5. From there, we are going to switch the positions of the x and y, which means x would come into the front of that equation, 3y minus 5. Our next step would be to solve for y. So little by little, we are going to move every single one of the terms that we have over to the left-hand side. This would turn into x plus 5 is equal to 3y, and x plus 5 divided by 3 is equal to y. Keep in mind, this can be written that way, or it could also be written as y is equal to 1/3 x plus 5/3. Once we have y isolated, we can then rewrite it as f of -1 is equal to x plus 5 over 3, or f of -1 is equal to 1/3 x plus 5/3. Now keep in mind, we have written down the f of -1. That does indicate it, but this is still a function, which means we will always have that x as part of our equation. Let's go ahead and take a look at slide 4. So in slide 4, we go over the step-by-step of how to solve for our inverse. Keep in mind, we begin with the f of x, we switch out with a y, we replace the y with x, and we solve for our y. Once we do that, we replace it with the f of -1 of x, and we have our answer. Let's take a look at slide 5. In slide 5, we have 3 different problems. What I highly suggest, go ahead, pause the video, work on these 3, or at least the first 2 on your own, and we will go over them together. So taking a look at example 1. With example 1, first thing we're going to do is set it so that y is equal to negative 2x to the third plus 1. X is equal to negative 2y to the third plus 1. X minus 1 is equal to negative 2y to the third. X minus 1 divided by negative 2 is equal to y to the third power. Now, keep in mind, this can be rewritten as a negative 1/2 x plus 1 is equal to y to the third power. Keep in mind, we are still needing to isolate the y, which means we would have to do the opposite of y to the third, which would be the cube root on both sides. Here we end up with the cube root of negative 1/2 x plus 1 is equal to y. And we would go ahead and write it as f of negative 1 of x is equal to the cube root of negative 1/2 x plus 1. Correction. Just noticed. That would be plus 1/2. So that negative 1 divided by negative 2, negative and negative will turn positive, and it will stay as a 1/2 all the way down. Let's go ahead and take a look at example 2. Now in this case, even though we are working with g of x, it may seem tempting for you to think, well, it's not f of x, so we can't replace it with y. It will always be equal to y, which means y is equal to negative x minus 5 over 3. We will replace our x and y. X is equal to negative y minus 5 over 3. First step would be to do the opposite, which in this case is to multiply 3 to both sides. 3x is equal to negative y minus 5. 3x plus 5 is equal to negative y. And y is equal to a negative 3x minus 5. We're going to go ahead and replace it with our negative 1 on the exponent of the g of x. And this would be our final answer. Now for a table. Generally for a table, we understand that this would be our f of x. When we insert a value for x, we come out with a value for y. Now the inverse would simply be when we switch the position of the x and the y. So in this case, if we were to have our x and y on our table, the numbers would take the place of the other. So in this case, if x was negative 2, our y now would be negative 2. If y was 4, now x is 4. And they switch the position every time. So if we were to go ahead and write down all of our x's in the positions of the y's, So -1, 0, 1, and 2. Our y's would go in the position of the x. So 4, 2, 0, -2, and -4. Let's go ahead and take a look at slide 6. In slide 6, this is a visual representation of what a graph would look like if we were looking at the inverse of a function. Generally, this is the line that the inverse would follow, which is that y is equal to x. So everything will be in reflection of that line. So depending on what our initial equation is, it will reflect that one line. So notice as we're running up through this line here, the reflection of that line, of its inverse, will take it through this spot here. The first question that's generally asked is, how is it that you're able to find that reflection? The same way that you would find multiple points on a line. You go ahead, you plug in a value for x, you come out with a y value. Now, the ultimate difference would be whether you're plugging in for f of x or whether you're plugging into the inverse, which would be the f of -1 of x equation. That will give you that ultimate inverse line that you are looking for. Let's go ahead and take a look at slide 7. So find the inverse and graph the function and its inverse. Ultimately, the first thing that we need to do is find the inverse. So we're going to go ahead. We have y is equal to 2x minus 3. X is equal to 2y minus 3. X plus 3 is equal to 2y. X plus 3 divided by 2 is equal to y. Keep in mind, we can simplify this a little bit better to be 1/2 x plus 3 over 2 is equal to y. So our inverse would be f of -1 of x is equal to 1/2 x plus 3 over 2. Now, before we start graphing the inverse, we need to find the initial equation and its line. So in this case, we know that y is equal to mx plus b. We know that our y-intercept for this problem would be 0, -3. And we know that the slope would be equal to 2. So let's go ahead and set up this first line at 0, -3. And we have a slope of positive 2, which means up 2 over 1, up 2 over 1. And we keep going in this direction until we get as far possible. And we're going to go in the opposite direction as well. We're going to go down 2, left 1, down 2, left 1. The entire reason behind doing this is to make sure that we have as long of a line as possible, so that wherever they cross, as far as the regular function line and its inverse, that you are able to see where they cross through. Let's go ahead and find the y-intercept for our inverse function, which is 0, 3 over 2, and our slope, which would be 1 over 2. 0, 3 over 2, which is the same as 0, 1.5, would initially be plotted there. We are going to go up 1 over 2. Up 1 over 2. Right there. Up 1 over 2. And we're also going to go in the opposite direction, which means we are dropping down 1, left 2, 1, left 2, 1, left 2. We're going to go ahead, connect our dots. So here we have our inverse line. F of -1 of x is equal to 1/2 x plus 3 over 2. And our secondary equation over here, which would be f of x is equal to 2x minus 3. Something to keep in mind, remember, this is all in reflection of the y is equal to x equation. That would be this line right through here. As you can see, once you see that y is equal to x line, it is a reflection of each other. Let's go ahead and take a look at slide 8. So much as determining a regular function and whether it is a function or not, there is also the ability to go ahead and determine whether the inverse is a function. In order to determine whether the inverse is a function, you are going to use a horizontal line test, and that is to determine the inverse function. Same rules apply. As you're drawing that line from left to right horizontally, it must only hit that line once. As long as it hits once, it is a function. If it hits twice, it is not. Let's go ahead, take a look at the example on the right-hand side. Here we have y is equal to 3x plus 2. As you can see, the line is moving through from left to right. It only hits it once as you're drawing that line, which means it is a function. Let's go ahead and take a look at slide 9. So we begin with one-to-one functions. Anytime that we have a one-to-one function, we are taking a look at one equation that is occurring, and we are going ahead and determining the inverse of the other. Now, this would be an example of finding points and then using those points to find the inverse. So let's go ahead and take a look at the function. Our initial function starts off as f of x is equal to x squared. A table has been formatted. As we plug in -2, we got 4, -1 is 1, 0 is 0, 1 is 1, 2 is 4, and 3 is 9. Keep in mind, when we find the inverse, or we are going to go ahead, we are going to find the inverse. If we were to work this problem out, y is equal to x squared. X is equal to y squared, which means y is equal to the square root of x. So f of negative 1 of x is equal to the square root of x. Now, as we get to this point, once we have established our x's and y's for our regular function, we can switch the positioning of the x and y, and we would come to the same answer. Keep in mind, when we're doing the square root of a number, for example, if we were to plug in 4, the square root of 4 would give us a positive or a negative 2. That is something to keep in mind. So, as we see 4 here, 4 would be negative 2. 4 would also be positive 2. For 1, 1 would give us positive 1 and negative 1. 0 would give us 0. And we go ahead and create our table. On the right-hand side, you can see how both of our tables create their specific graph and the image that it gives. As you can see, it does reflect over the y is equal to x line. Now, as we take a look at our original function in blue, in that case, we would do a vertical line test for that original function, but we would do a horizontal for the inverse. In this case, as you can see, both the vertical line test and horizontal line test would pass for each one of these different functions. Keep in mind, you can only do the vertical line test for a regular function. You can only use the horizontal line test for the inverse function. Let's go ahead and take a look at slide 10. So, as we go ahead and we are taking a look at a graph, if we are looking at the original graph itself, how to determine if a function has an inverse function? Well, generally, if it's just a function, we're going to go with f of x. We're going to do our vertical line test to determine whether it is a function or not. In this case, it is a function. If we were doing the inverse, we would have to go ahead and do a horizontal line test. As you can see, in both cases, they are both functions. Now, our equation on the left-hand side, or our function on the left-hand side, is a function as its original function as well as the inverse. The example on the right-hand side cannot be the same because as we run that vertical line test, although we do pass, what definitely does occur is that after a certain point, if we are doing the horizontal line test, notice that horizontal line point is going to hit at multiple spots, which means our f of x, yes, it is a function. But our inverse, or f of negative 1 of x, is not a function. Let's go ahead and take a look at slide 11. In slide 11, we have the ability to determine whether two functions are inverses of each other. Generally, what will occur is that we have the ability to go ahead and plug in each function into the other function. We are basically doing a composite or composition function of f of g and g of f. Once both have been solved, they should end up equaling x. If our final answer for both f of g and g of f are x, in that case, they are inverses of each other. So let's go ahead and work these problems out. Let's start off with the left side, which it says f of g. So with f of g, we take a look at our g of x equation, and we are going to plug it into f of x, which means 2 times 1/2 x minus 4 plus 8 would be our f of g equation. We distribute the 2, which means x minus 8 plus 8. Notice in this case, our plus 8 and minus 8 cancel out. Our final answer on our left side for f of g of x is going to be x. We're going to go ahead and do g of f of x. So in this case, f of x would go into the g of x equation. So f of x is 2x. So we start off with 1/2 times 2x plus 8 minus 4. 1/2 of 2 is x. 1/2 of 8 is 4 minus 4. Keep in mind, minus 4 and plus 4 cancel off. X would be your final answer. Because we have an x on the left, we have an x on the right. Both are inverses of each other. Let's go ahead and take a look at slide 12. So take a moment to work this problem out on your own. Pause the video, and we'll go over it in 1 second. So in this slide, we're going to begin with our f of g of x. So we begin with 3 times 1/3 x plus 1/3 minus 1. 3 times 1/3 would just be x, or 1x, plus 1 minus 1. In this case, minus 1 and plus 1 cancel off. We are left with x. G of f of x would start off with 1/3 times 3x minus 1 plus 1/3. 1/3 of 3 is 1x minus 1/3 plus 1/3. Positive 1/3 and a negative 1/3 cancel off, and we end up with a final value of x. In this case, they are both inverses of each other because of the fact that both sides, the f of g of x and our g of f of x, both are opposites, both are x's and are inverses of each other. If you have any questions, please feel free to ask at any point.